Okay, welcome back to the part 2 of this video. So we were discussing the probability questions and let us do at least 2 or 3 of them. Let us look on to this question. What does this question say? So the question says that you have to assume a sex ratio of 1 is to 1 and what is the probability that a family of 4 children. So see, n is 4. The number of events here 4 are there will consist of 3 daughters and 1 son. So if we are given 3 daughters and 1 son, there is no such sequence mentioned. So when the sequences are not mentioned, that time we can use the binomial theorem. Now what is binomial theorem? Binomial theorem is used to calculate the probability and it is n factorial upon the whatever are the two events, means the two further sub events, which is s its factorial multiplied by t its factorial, then multiply by p, the probability of event s to the power s multiply by q, the probability of another event to the power t. This is the golden formula for the binomial theorem which we are going to use in these questions. So when we are asked the probability of 3 daughters and 1 son, so we simply say that here the s comes out to be 3 and the t comes out to be 1 and n is always 4 in this question. So the probability comes out to be 4 factorial upon 3 factorial 1 factorial, and now we know that for daughter and son the probability should be half because either can be born, so here it is half. The chances are half, right? S is 3 and for the sun also the chances are half to be born and t is 1, that is number. Now how to solve this? We know for finding the factorial we start with that number only, so it is 4 3 2 1, here 3 2 1, then here 1, then here we can solve 2 into 2 into 2, and for this 2 also you can write it here only, multiply by 2. Now this is what you can solve. Let's move to the next part of this question. The next part simply says that what if we have all the daughters. Now in the condition of all the daughters, the n factorial was 4. Now s is becoming 4 and this is becoming 0. This is 1 only, okay? The factorial of 0 turns out to be 1. For daughters it is 4 and for son it is 0. So this will also turn out to be 1. So I can eventually eliminate this and this. Now what is left? This and this gets cancelled. So here I get 1 by 16. The same goes for all sons also. Alternating sexes. Now see, either I can get here, this is important question, you see, either I can get boy, girl, or I can get girl, boy, boy. So if you look into this carefully, I have got a sequence. So whenever I am getting a sequence, now I cannot use the binomial theorem. Now how to solve this? See, I'll solve it here only. So yes, boy. Now see, the first one should be boy. Now getting a boy as a first child is half. We know the probability is half. The second as a girl, again it should be half because here individually the girl can either be born or either not be born. Similarly here also half and here also half. Now if you come to know at the fourth of these events depict four different children. So do you think that they depend on each other? Do you think that the first boy being a boy is dependent upon the second girl? No. So when the dependency is not there, we simply use the product rule. The answer comes out to be 1 by 16. And here also the answer comes out to be 1 by 16. Now again, consider, do you think that this sequence, because we are asked either sequence, no. So do you think this sequence is dependent upon this sequence? No, it is not dependent. So again we are using here the product rule and we get the answer as, oh sorry, my mistake. Actually you see, these are dependent. Why? Because these are mutually exclusive. Either this can happen or this can happen. See, we only have to get one sequence, right? So either this can be the case or this second sequence can be the case. Means if this is there, this will be excluded, and if this is there, then this would be excluded, right? So here the either this can happen, either this can, so it is the mutual exclusive, so we have the sum rule here. So if we are applying the sum rule simply, it comes out to be 1 by 16 plus 1 by 16, that is 2 by 16 or 1 by 8. So our final answer comes out to be 1 by 8. Let's move to another set of questions, the similar set of questions. Okay. And again, this question is also important. At least two daughters. So at least two daughters we have means S can be either 2, S can be 3, and S can be 4. In this condition we know T can be 2, T can be 1, and T can be 0. And always N is 4. And we know P is half and Q is also half. So you can easily apply binomial theorems for the three cases and you can solve. But there is another important law which is what we call as Pascal's law. Again, the video was deleted and I explained everything, but again I'll explain it to you. No worries. See, I'll simply try to explain what the Pascal rule or what the Pascal law says. We don't need to go into the details of what actually is the Pascal law and how to solve it and everything. We have to just use it for our formula. It is a mathematical law which talks about the probability again. So here the Pascal's law is considering two events at a time, P and Q. Now P is the probability of occurring of event 1 and Q is the probability of occurring of event 2. And 0, 1, 2, 3, 4, these are the number of events, the total number of events. So in our case, we had total number of events as 4. The probability of occurring of event P was half. The probability of occurring of event Q means boy. So this condition can be applicable. Now see, how to solve this condition? The condition is quite doable. If you decode and if you try to solve this P plus Q power 4, so P plus Q power 4, the value comes out to be, see, it can be P4 Q0, then it can be P3 Q1, then it can be P2 Q2, it can be P1 Q, sorry, it can be P1 Q3, and lastly it can be P0 Q4. Now if you know how to write this Pascal's triangle, I'll tell you how to write. But see, now what you need to do is the next thing is that you have to just write the numbers after this. So after this term you will write this number, that is 1. So I'm writing here for you. It will be here 1, then 4, then 6, then 4, then 1. Now see, our condition was either we can have two daughters, either we can have three daughters, and either we can have four daughters. Means P can be 2, 3, and 4. So consider those cases here. So here the P is 2, here the P is 3, and here the P is 4. So you have to just put the formula, the values in the formula, and you can get the answer. So for this one, I will use this 6 into P. What is the value of P? It is half to the power 2. Multiply by Q, it is also half to the power 2. And you can solve it. It's very simple. If P is 3, so use this formula 4 into P. P is half to the power 3 multiplied by Q is again half to the power 1. And for this one, lastly, it is 1 multiplied by half to the power 4. So the Pascal's law, if you know how to write the Pascal's triangle, it is very easy to solve these kind of questions where you are getting the word at least. Because in that condition, always using binomial theorem is a very cumbersome procedure and very time consuming procedure. How to draw the triangle? See, for P plus Q equal to 0, it is 1. P plus Q bar 1, it is 1 and 1. And then it's very simple. See, 1 and 1, 2. Then you have to add this and right here. Add this and right here. Then add this right here. Add this right here. Like this way, you have to continue the entire Pascal's triangle. And you can get these values also in between. So this is very important and the numbers play a very significant role. You cannot avoid these numbers. So that is how we solve the questions using the Pascal's law. So these are the two important cases I told you. I also had one more question for you, and this also I solved, but now again I have to solve it because everything got deleted. So I'll solve it again for you here only. See, the question is very simple. but there is a slight difficulty in the question, and that I'll explain you that how do we solve this question. The question is based upon the tasting of compound called PTC, right? It is a compound PTC. Now here it is dominant to non-tasting, means those who have TT or those who have this, they both are tasters, but this condition is not taster. Now there is a taster man, but who is a non-taster? It means the question actual was whose mother is a non-taster. So if mother is a non-taster and she's marrying her husband and the man is taster, what do you think what kind of taster a man can be? He must be heterozygous. Mary is a taster woman who in the previous marriage had a non-taster daughter. Now this woman in the previous marriage had a daughter which was non-taster. Getting it? So it is small t. How can she become small t when here also one of the recessive allele is present? Means the woman is also heterozygous. So what I am trying to say is that the man is capital T small t and the woman is also capital T small t. As simple as that. Now the question, once you decode the question, now the question becomes easy for you. What the question is saying, now what is the probability? So first of all we will write here that this, when the two of them are crossed, we can get these chances, right? Now the probability for the their first child as a taster, so the first child being born as a taster, what do you think the probability can be? It can be 3 by 4 because it is a dominant form. Their first child a non-taster boy, it can be simply 1 by 4. 7 children with 4 tasters and 3 non-tasters. There is no sequence mentioned. So I told you here you have to simply use the binomial theorem where 7 factorial upon 4 factorial multiply by 3 factorial, and what is the value of p? P is the probability of tasting, that is 3 by 4. Now it is not the condition of half. Half was the condition in boy and girls. Here it is about tasting and non-tasting. So p becomes 3 by 4 and its power is 4. Multiply by 1 by 4 and its power is 3. And then you can solve this question. Lastly, 5 children of whom 2 taster, this order. So when the order is given, that time you cannot use the binomial theorem. You have to just write that okay, the first boy, there are 2 boys who are taster. So he is a male. Okay, let me write it like this way only. So he has to be, there are 2 boys and both of them are taster. Okay, then there should be a taster girl, then there should be a non-taster boy, then there should be a non-taster, wait, a non-taster girl. What do you think the chances are? Firstly, let's decode this. For being a boy, the probability is half. For being a taster, the probability is 3 by 4. And why multiplying both of them? Because both of them do not depend upon each other. Secondly, for again this, the same thing I'll apply. Thirdly, again I'll apply the same thing. Fourth, being a non-taster, the probability is half, and being a boy, the probability is half. And sorry, being a non-taster, probability is 1 by 4. Fifth, being a girl, probability becomes half, and being a non-taster, the probability becomes 1 by 4. And since all these events also do not depend upon each other, so we can here write multiply. And whatever the final answer comes will be your probability of that particular sequence. So this is how we solve the probability questions.